What happens if you try to differentiate trigonometric functions? The sine, the cosine, and the tan. One way of thinking of this is thinking of the derivative as the tangent of the function at a point. I'm starting with a sine, here represented in green. And I'm going to use the marker to look at the tangent at every single point. I'm starting over here when the sine is 1. All right, this happens when x is pi over 2. What is a gradient? It's 0. As it gets from pi over 2 until pi, the value of the gradient is getting smaller and smaller. This is going to be as small as it gets when the angle is pi, and then it starts getting less small, so that it is 0 again. This happens when the sine of the angle is minus 1. The sine of the angle is minus 1 when the angle is 3 pi over 2. And then it starts getting bigger and bigger and bigger until it gets the maximum value when the sine of the angle is 0, that is at 2 pi. All right? So the inclination of this marker will tell you the value of the gradient. See, here is 0, 0. Here is the minimum, over here, minus 1. Here is 0 again, 0. Here is maximum positive, over here. So at blue, you will have the value of the derivative of the sine. And if you look at this blue shape, what is this? This is just the cosine. So if you differentiate the sine of x, the result is going to be the cosine of x. More generally, if you want to differentiate the sine of ax, in which a is a constant, then the result is going to be a cosine of ax. You can use the same approach to get the value of the cosine of x. Again, look at what's happening over here, and then try to plot it yourself. 0, maximum negative, 0, maximum positive, and this is the shape that you'll get. What is that? This looks like the sine, but the sine is the other way around, right? The sine is like this. So what is this? This is minus sine of x. If you differentiate the cosine, you'll get minus sine of x. More generally again, if you differentiate the cosine of ax, in which a is a constant, you will get minus a sine of ax. What about the tangent? Do the same thing. What is happening to the gradient? This is as big as it gets, starts getting smaller and smaller and smaller. Here eventually is 1, and then starts getting bigger and bigger and bigger and bigger again. And then starts repeating the whole thing itself. So this is it. Almost infinite, starts getting smaller and smaller. The minimum value is 1, and then starts getting bigger and bigger and bigger again. What is this shape? You may recognize this from the previous chapter. This is not exactly, because what you learned was the second, not the second square. You just have to take my word here for it. So if you differentiate the tan of x, the result is going to be 1 over the cosine squared of x, which is the second square of x. Again, more generally, tan of ax, if you differentiate this, is going to be a second square of ax. And that's all that you need to know. Again, these results can be found here on the MF19. Sine, cosine, tan. Then you have here also for the second, the cosecond, and the cotangent, but you don't need to know this for now.